Hello everyone, our ISC topic is cyclic code. Let's start with it. So, what is meant by cyclic code? A cyclic code is a subclass of linear block code. What is meant by linear block code? A code is said to be linear code if the sum of any two code words gives another code word. So, code word is divided into two blocks. One is k bits and another is n minus k bits, where n is the length of the code word and n minus k is the parity check bits and k is the message bit. Also, a linear block code is a linear combination of a parity bits and message bits. There is one example. If we take two code words, first one is 0101, another one is 1010. If we add them, then we get another valid code word, that is 1111. Coming to the cyclic code, if n, k linear code is said to be cyclic if it follows two properties, that are linearity property and cyclic property. Then in the linearity property, there are three conditions. First one is all zero word is valid code word. It means 0000 is also a valid code word. Then another is the sum of two code word also from a valid code word. If we have 0101 and 1010, if we add them, then we will get 1111. It is a valid code word. Then another, the minimum distance between two code words is equal to the minimum Hamming weight. So that means D of minimum is equal to minimum weight. So here we have example. We have 0000 and 0101. If we want to check the weight of a code word, we can find it from the non-zero elements in the code word. For example, we have 0101, that is code word we have. There are two non-zero elements, so the weight of the code word is 2. If we have to check the distance between the two code words, we have to compare with their positions. So the another property is cyclic property, also called as cyclic shift property. There are two shifts, one is right shift and one is left shift. So the next point is importance of cyclic code in cybersecurity. First is data integrity. Cyclic codes ensure that transmitted data remains intact for secure communication. Then the second point is error detection. Identifies any discretization in the received data, allowing from promote error correction in cyber system. Then the next point is resilience against attack. Acts as a defense mechanism against data tampering or manipulation by unauthorized sources.
There are various uses of cyclic code in cybersecurity. First one is data integrity. In the data integrity, we ensure the data remains unchanged throughout its life cycle. Second one is error detection. In the error detection, we identify and correct the errors in transmitted data. Third one is message authentication. In the message authentication, we verify and integrate the origin of message to prevent unauthorized access. There are mainly two processes of the cyclic code. First one is sender side processes and second one is receiver side processes. In the first process, sender side process, there are mainly three steps. First one is data encryption. In the data encryption, we convert a plain text into a ciphertext using a specific algorithm. In the second step, adding redundancy, we introduce a redundancy to detect and correct the errors in the transmission. Third step is generating checksum. Here we create a checksum to verify the integrity of the transmitted data. Second process is receiver side process. In the receiver side process, it involves decoding and interrupting the received cycle code to extract the original information. It includes error detection, error correction to ensure the integrity and accuracy of the message. There are various applications of cyclic code exist. First one is integration, seamless integration with existing security systems for enhanced protection. Second one is performance. In performance, optimizing performance without compromising security measures. Third one is scalability, adaptation to varying system sizes and complexities. There are the advantages and disadvantages of cyclic code in cybersecurity. Advantages are enhances security measures, and the disadvantages are potential for increased complexity.
Cyclic code example. So example is design R encoder for 7 and 4 binary cyclic code generated by g of x is equal to 1 plus x raised to 3 and verify its operation using message vector 1010. So it's solved. So answer is the question R. It is the 7 and 4 are cyclic code. We can say that n is equal to 7 and value of k is equal to 4. So number of shift register is equal to n minus k, and number of value of 7 is equal to n and value of k is equal to 4. So 7 minus 4 is equal to 3. So 3 shift register are required to design encoder, and 3 shift register are to be R0, R1 and R2. So these 3 shift register are required, and design we equation about in this diagram. So diagram is the parity, we can say XOR gate, and R1, R2 and R0 are connected in one diagram. So given example is g of x is equal to 1 plus x raised to cube, and coefficient form of g of x is equal to 1 into x raised to cube plus 1 into x raised to 1 plus 0.x raised to 2 plus 1 into x raised to cube. These are the coefficient form of a given equation. We can say that g of 0 is equal to 1, g of 1 is equal to 1, g of 2 is equal to 0, and g of 3 is equal to 1. So we can calculate the coefficient of a generator, polynomial and value of put in figure. So now the consider R2, R0 input and output and R1 input and output and R2 input and output shown in the diagram, and these are the 3 register input and output. So next slide is, in this diagram one gate should be there which act as a switch, and now solve the expression of input 3 shift register, that is we can say solve expression of input of this 3 shift register, that is R0 I is equal to R2 raised to 0, and R1 of input is equal to R0 raised to 2 R into R raised to 2. And for these 3 expressions, we 3 shift register of the solve is equal to R0 I is equal to R raised to 2 output plus m, and these are the 3 now latest perform of the 3 expression. So next slide is solve the diagram about register inputs and register output. You can say and see that we can say that the code of vector for the message 1010 is 110, that will be message 1010. Message given us that output parity. Thank you.